Hi everyone, welcome to this video on functions in math. So don't worry, we are not going to do some technical things and those kind of things. We're gonna explain the concept of functions. It's not, you know, intimidating as it sounds. I just want to give you some, intuition or visual understanding of what is function. Once you understand the basic idea, you'll see the functions of everywhere, in video games, in your paycheck, even in Google Maps. Whether you heard of the term before or this is your first time, by the end of this video, you'll understand what a function is and how it works and why it's useful, even outside of the math class. So let's start with the game. Have you ever played Flow Free? In this game, you connect matching colors with pipes. But here is a twist or rule. Each color must connect to only one other point, and the pipes cannot cross. So we can say, just like as you see here, if you now connect, for example, green to the green by passing by on the brown, so lose the game. What can we do is to show that the function are exactly work like this game. You can map the board game to the Cartesian plane that you have already know. So this is the plane that all the things happen on it. So this is the board is like the XY plane. And you can say in for the pipes, the starting point is the input. For example, the red one, starting point is 3, and the destination point is the output. And we go for the green, starting point is 2, and give a value to the destination point like 4, and the blue starting point is 1, and the destination point is 3. So we're gonna show these numbers in the plane. It would be something like this, 1, 3, 2, 4, 3, and 5. So if we continue to draw that, have a line. So this is a great way to picture how functions work. In a function, every input can connect to only one output, just like in the game. If a color tries to go to 2 places, it breaks the rule. Functions are all about consistent connections. If an input connects 2 different outputs, it's not a function. Just like when 2 pipes cross in flow free, it causes a mess. So always remember, a function is like a one-way pipe from one input to one output. No splits, no branches. So what is a function notation? How do we write a function in the language of mathematics? Let's use this link. We have it. Okay. So we can say it's like a visual function machine. Now, we have one input, and the function is like a number that goes, it's a rule that applies on this input and gives you this output. So we call that output f of x. we say f of x because we are applying the function f to the input x. But for example, we have a function here. Simple example, f of x equals to 2x plus 3. This just means take any number x, multiply it by 2, then add 3. So if x equals to 4, then f of 4 is 2 times 4 plus 3, which equals to 11. So we say f of x because we are applying the function f, the input x. You can also model real life situations like, for example, your pay is, salary calculation. F of h is 15 times h. H is the hours that you work, and 15 is the money you are getting paid, $15 per hour. So if you work 10 hours, f of 10 equals to 150. That's how simple functions can describe your job income. So we use functions everywhere. Let's look at it another way. A function is like a vending machine. You press B2 and it always gives you a soda. If it sometimes gave you chips or nothing at all, that's not a function, that's frustration. This rule that every input must match just one output is what makes functions so predictable and powerful. And another example. Another way to think about function is through something we all use every day, GPS. Let's say you're at location 2 and 3 and you want to get to a coffee shop. You put your location into the GPS and it gives you one clear route. That's a function. Your input is your current location. Function is the GPS algorithm. Output is the direction. So what if the GPS gave you different routes each time, or 5 routes for the same spot? That would be chaos. That's why functions are like good GPS systems. They are predictable and reliable. One input, one output. What type of relation? We talked about the, let's now talk about the relations and how they're different from functions. Imagine this. You enter a number into a strange telephone. You can play with this link. So you enter a number in it. The phone rings back with a number. For example, you input 1, it rings 6 times. We're gonna try again. Same number. Every time I click the transform, it gives us the same number. So you try the same number and it gives you a different response. Is that okay? No. Function is a special kind of relation. It's a rule that assigns each input to exactly one output. You can guess what is, the relation here. I give it 1, it gives me 6. I give it 2, it gives me 7. So it's the same rule for our numbers. Just add 5 to the input number. Or I'm gonna go for this word. A square function, so I have 3, I can guess should give me 9. So if I add 6, I will have 36. If you ever see the same input leading to 2 different outputs, that's not a function. This game will help you build intuition. Functions are about the consistency and predictability. We're gonna continue here. Next one, okay. functions as a vertical line test. So let's now talk about how to visually test if something is a function. Here's a trick. Draw a vertical line and the graph. If that line touches the graph more than once, it's not a function. Like here in the circle, draw a vertical line and it crosses two twice. It's not a function. So why is like that? Why it's work? Because the x value on the x-axis is being used twice with different y values for different outputs. As we know, one input, one output, like the function that we are here, like y equals to x squared, or y equals to sinus x. So anytime you have two or more, it's not a function. This visual trick is super useful in algebra and the calculus. Once you get used to it, you'll be spotting functions everywhere. But we talked about a lot talked about the inputs, the x-axis, and the outputs. What do we call them? Call them in mathematics? Domain and range. The domain is the set of all possible input values. A fancy way of saying what can I plug into this function without breaking it. Think of a domain like a booth. If a value isn't allowed in, maybe it causes division by 0 or a negative under a square root, it's not part of the domain. For example, we have f of x equals to a square root of x. So we cannot plug in negative numbers. Therefore, the domain is x greater than or equal to 0. Or we have f of x equals to 1 divided by x minus 2. We can use x equal, we can use 2 as the input because it would be divided 1 by 0. So here's the domain is all real numbers except 2. Now what is range? Range is the set of all possible outputs a function can give. So the function becomes, after plugging in allowed values of x, what kind of y values can I get back? Some examples. For example, if f of x equals to x squared, you can never get a negative output because multiplying two negative numbers gives you positive numbers. Minus 1 multiplied by minus 1 gives you 1. So the range is all the y's more than 0. Or with the linear function, normally the range is all the real numbers. So we have two key questions. What x values break the function? That gives you the domain. What kind of y values are actually possible? That gives you the range. So do you want to practice? I have another interactive link. Here it is. So here I just put for common functions that we use in everyday life. For example, we can call them, just see them as different flavors. Linear function, quadratic function, rational function, and square root. You can try them. This interactive tool shows you in the example what is the, what the function looks like. If you give them the input, it will shows you the exact outputs and will gives you the domain and the range. For the blue line, the valid inputs, here, this is the the Cartesian plane. The blue line gives you the input. The red red line here is the function. and the purple dots is a value. So for example, I go from here. I give you 1 using trees. It goes up the same steep. So now my domain is all real values and my range is all real values. Let's try another type of function here. For example, quadratic function. Call this U-shape. This one is f of x equals to x squared minus 4. So go here, go to the list one, we can have 0, and it gives us minus 4. So our range starts from minus 4, goes on, and our domain is all real numbers. Let's go try another one, for example, the rational function. This is the rational function. It's a weird function, but our range is different. We will have almost all the range, but for the 0. For 2, let's see what happens when we go 2. 2, look, it's undefined, because if we put here, instead of x, we put 2, we had 1 divided by 0. So our domain is all real numbers except 2. And our range is all real numbers except f(x) equals to 0. So you can use this to see how the functions work. You have the square root as well. Show you, but I'm not gonna go into the detail. We can use these, for example, here, make it 6, 0, so like this. Let's wrapping things up. I'm just gonna review what we talked about. The function is a rule that assigns every input only one output. Function notation helps us describe real-world problems. We have some visual, tools like graphs and games to help us understand how functions behave. You can even have a vertical line test to check the graph of the relationship to understand is the function or not. We should use the domain and the range to understand what a function accepts and what it produces. Functions are everywhere in games and GPS and science. Just remember this one. One input, one output. That's the function way. I hope you like this video. I'm going to describe the other, mathematical concepts and explain them in a visual way as we have today. And if you have any subject that you think you need some intuition on it, just write it in the comments, and I would be happy if you subscribe and share the video. Until the next video, bye.